Hello students, welcome back. Let's go to problem number 4. This is a continuation from the previous problem. The same poll data related to 2016 presidential election. Please be warned, this very problem number 4, did not really turn out really useful in terms of application. Mathematically they make sense, but it didn't really turn out interesting. And number 5, this one turned out a little bit interesting, but that's a bit advanced. So please regard this problem number 4 as a kind of stepping stone toward the next problem. Okay, here we go. The most recent poll conducted by CNN-ORC, May 3rd, 2016, found Hillary Clinton leading Donald Trump by 54% to 41%. This poll result is based on a total of 890 registered voters. On the other hand, the most recent poll by Fox News, April 14, 2016, has Clinton leading Trump by 47% to 40%, based on 1,021 likely voters. It appears that there may exist a significant difference between the Clinton supporters between the CNN-ORC poll in May 3rd and Fox News poll in April 14th. So let's set up these hypothesis testing. CNN-ORC poll gave Hillary Clinton 54%. So let's compare that with the figure by Fox News, which is 47. So let's set up a question and then do some hypothesis testing. The CNN-ORC poll suggests the projected proportion of Clinton support exceed 47%. So even though this 47% did come from the poll, if you look at this problem only, it has nothing to do with CNN-ORC poll. So this is null. Can get a little bit tricky. Usually null is not coming from sample study, but in that sense, as a matter of fact, it's true. It came from completely different sample studies. So as far as CNN-ORC poll is concerned, 47% is not related to that. So it's null. It's null hypothesis. And we can set up hypothesis like this. The real proportion is 47%, yeah, but somehow we ended up getting 54% by some sheer luck. Or alternative hypothesis is, no, really the proportion is greater than 47%, significantly greater than 47%. Based upon this, let's do some hypothesis testing. Okay, in this case, level of significance is 1%, 0.01, and let's begin. First, my favorite method, critical value approach. So we go like this. The sample statistics, we have, let's see, alpha is 0.01, n value, sample size is 890, and then observed mean or observed proportion is 54%, 0.54, and then standard error is as we calculated over here. Tricky part, this is null, this p0, the probability is null. That's why I'm putting this little 0 here to emphasize this is null, okay, not the other probability, not 54%, it's 47%, 0.47, 1 minus 0.47 divided by 890. If you calculate it, you're going to get this standard error, 0.0167 something, and this is going to go down to the denominator. Okay, next, here is the initial picture. As usual, you have the null at the center, and then alternative hypothesis is greater than null, so we have this critical value to the right. Greater goes to the right. And then where does 54% fall? Does it fall here? then null wins, close to null. Does it fall here in the red region? Then it's going to be alternative winning. So we reject null and take alternative. It depends heavily upon what this critical value is, and let's find out. How do we do that? The same formula, n minus center over SE is 2.33. Please remember we are using the SE, standard error we calculated before. Over here, this computation we did in the previous step. All right. Excuse me. Maybe I'll just copy and paste this thing over here so that I don't have to go back and forth, back and forth. Okay, that goes down to denominator. And n minus center over SC is 2.33. By the way, this is Z table, and 2.33, actually it's the other way around. I want 99% here and 1% over there. So, okay. 2.33, yes. This is the closest to 99%. So we select 2.33 as your Z-score. So n minus center over SC is 2.33. We can solve this equation. Flip the denominator to the other side and flip over this center, and we get 0.47 plus the Z-score 2.33 times standard error, and we ended up with 0.508 something, and this is the critical value that will go right here. Now this is about 50.89%. Where is 54%? It's way over there. And we get the conclusion. We have 54% here, way over there. So based upon CNN ORC poll, yes, alternative wins. The proportion of Clinton supporters is significantly greater than 47%. Based upon CNN ORC poll, of course. Now, how about the next problem here? Do the same. Basically do the same to Fox News poll. Does the Fox News suggest the projected proportion of Clinton support is below 54%? So forget about the CNN ORC data and use 1,021 likely voters, and then these sample statistics from Fox News only, and use 54% as just null. Just like we did before, you can set up hypotheses and then test it. However, I didn't do any of these. I'm going to leave these problems to you. Instead, let's repeat the same problem using the probability value method. Okay, how does that thing work? Well, initial picture differs a little bit. The null is, of course, 47%, but the observed mean comes already. Instead of looking for critical value, we put observed value 0.54 and find out appropriate shading here. But look at this picture. I drew it in real scale, and then I cannot even see anything here, which means this probability is going to be extremely small. If you drew the picture in hand-drawn picture, then maybe you can't see this, but you'll see that this probability is so small that alternative clearly wins. But, well, let's do this computation anyway. So t-score is n minus center, 0.54 minus 0.47 over SC you calculated previously. Run your computation, you're going to get 4.18 something. And this is such a humongous value that if you go over to technology aid and do some computation, probability that the z-score exceeds this 4.1 something is pretty close to zero, as a matter of fact. So small that it doesn't even appear in the standard z table. I mean, it ends at 3.4, and as you can see, 3.49, really, 0.9998, you see, and then negative 3.4 something, and this 0.0002, it's this small, see, really small, and then we're talking about 4.18, that's even bigger, so even smaller probability that null is right. So clearly, null is rejected out and alternative wins. I told you already in advanced warning, as a real-life application, this problem did not really turn out an interesting problem. Mathematically still, it made a bit of a sense. I'm going to skip talking about hybrid method or confidence interval method. And let's say this problem number 4 is done. And in a separate video, let's discuss problem 5.